Okay guys, so I'll start off on page 66, question 3, part 1. Right. So we have a quadratic x squared plus 4x minus 6. We can't write that as a perfect square. Okay. In the question they actually ask us, they say write each of the following in the form, and here it is, x minus p squared plus q equals 0. Now when they say that, they mean write it in, a perfect square plus the number equals 0. Okay, so they're telling us how to write it. They could also say complete the square. If they say that, we have to write it like that as well. They could also say find the minimum value, in which case we have to write it like that and take that as the y number, change the sign here as the x number. Okay, so back to this question. We can't write that as a perfect square. Okay, it just doesn't work. So in order to be able to write it as a perfect square, I'm going to half this value. So half 4 is 2, and then I'm going to square it. 2 squared is 4, so I'm going to add 4. Okay, now just to keep it together, I'm going to take away the 4 now, and there's my 6. Okay, so x squared, that's that, I added 4, then I took away 4, and there's my minus 6. Now I'm going to write this as a perfect square. So x plus 2 squared. How do I know that? Well, I know it because I look at the last number and I get the square root of it, which is 2. And then I look at this sign and it's a plus, so it's a plus here. Now take this bit. Minus 4 minus 6 is minus 10 equals 0. Now, I'm after writing this in that form. Out of interest, not that we're asked, but out of interest, the minimum point is, well, the y value is minus 10. I take that straight from here. The x value is, again, I change that sign so it becomes a minus 2. So that's the minimum value. Okay, so just to get a visual representation, this is a U shape, and this bit here is minus 2, minus 10. Okay, so that's that done. Right, next one. X squared minus 7x minus 3 equals 0. Okay, and we are asked again to write it in this form. Right, let's go. Not a perfect square, so we're going to have to manipulate it. Half this and then square it. Okay, so I'm going to need my calculator for this one because there's going to be fractions. So x squared minus 7x. Half 7 is 3.5 multiplied by 3.5, which will give me, and I'm going to keep it as a fraction. Okay, so it's plus 49 over 4 minus 49 over 4, and then minus 3 equals 0. So let's have a look. I halved it, I squared it, I got 49 over 4, I added it to it, then I took away the 49 over 4 and I brought down by 3. Yeah. I don't know by looking at it. If someone gave me that and they said it's a perfect square, I wouldn't have a clue. But I know it has to be a perfect square now because I'm after making it a perfect square. I'm after halving that and squaring it. Every time I do that, it's going to be a perfect square. So this will be, yeah, it's going to be a minus because that's a minus. 49 over, 49 over 4, and I get the square root of that. So square root of 49 over 4 equals 7 over 2. I'll rewrite that. Minus 7 over 2 squared. Okay, again going back, half that squared, I get that, add it to it, then take it away, and then bring down our 3. take that. I know it's a perfect square because I'm after halving that and squaring it and adding it in. Get the square root of that, put it in here, and I have x minus 7 over 2 squared. This, if I was to multiply it out, would equal this. I still have to deal with my 49 over 4 minus 3 equals 0. Okay, nearly done now. So x minus 7 over 2 squared, and then we have 49 over 4, and which will give us minus 61 over 4. Okay, and if you wanted to change that 61 over 4, it's x minus 7 over 2 squared minus 15.25 equals 0. Okay. Right, so this is page 66, question 4, part 3, part I. And we're asked to find the minimum point. So find the minimum point, we're looking for a point with a y value and an x value. If we can write this, I suppose, in the completing the square format, okay, then we can find it very quick, easily. And the problem with this one is, look, that 4 is wrecking everything on us. So, as we slowly did in class the other day, okay, like pulling teeth in there, we had to get rid of that 4. Now, how do we get rid of that 4? Okay, how do we get rid of the 4? Well, we'll divide across by 4. This is an equation though, right? So I'm just going to divide the whole way across by 4. So 4x squared divided by 4 is x squared. Now this is where it gets really messy, and this is going to get messy, but there's nothing we can do about it. So x divided by 4 is a quarter x, and 3 divided by 4 is 3 over 4, 0. Now, this has to be the same as that. At the moment it's 4 times smaller because I'm after dividing by 4. So I'm going to have to do that. So really what I'm after doing is I'm after factorizing this. Okay? I have to take the 4 out, and I'm after reducing everything by 4 times that. Right. Now, and this is going to get messy. We'll have the 4 outside it. Now, a quarter halved is an 8. Okay. So again, why am I doing that? Well, because I have to half the middle bit. So a quarter halved is an 8. And then I need to square it. So I need the calculator. So yeah. So it's plus 1 over 64. Okay. Minus 1 over 64 plus 3 over 4. Okay, so again, this is the same as this. I have my x squared, that, and then I have plus 1 over 64 minus 1 over 64. I'm getting the 1 over 64 from halving the quarter, which will give me an 8, and then squaring it. Okay? Now, I am going to take this, because I know it's going to be a perfect square. How do I know it's going to be a perfect square? Because I've halved the middle one and then squared it. So that has to be a perfect square. So the 4 outside. Inside then will be x. Now that's a plus, so this must be a plus. And I will get the square root of 64, which will be 1/8. Okay, so after dealing with that, minus 1 over 64 plus 3 over 4 equals 0. Okay, now I'll deal with this inside the bracket. Just could bring it all outside, but I'll deal with it inside the bracket first. Plus 1 over 8 squared. Now again, you need your calculator, so it's 1 over 64 plus, sorry, okay, so this minus this is 47 over 64 equals 0. Okay, still not finished though. I'm going to leave this inside and I want to take this out. And the way I can take that out is that's basically saying 4 times this. So if I want to take it out, I'm going to have to multiply it by 4. 47 over 64 multiplied by 4 is 47 over 16. That's a plus. Equals 0. Okay. Right. So, I'm asked for my minimum point. That's my y value. Change the sign of that. It's my x value if I change the sign. Okay? So, the value I will have is 47 over 16. You change it to a decimal if you want, but it's easier to work in fractions with this. Okay, decimals gets a bit messy. Minus 1 over 8. Okay, what is that? It's the minimum value of this curve. Okay. Okay, last question. First part is, this is question 5, page 66. Complete the square of this. Okay, now you'll notice they actually have a k here rather than a number. We don't care so far. Okay, we'll complete the square. So, first thing we'll do, x squared minus 6x plus k, and I presume it equals 0. It's meant to equal 0, but anyway, I'll let it equal 0. Right, I want to complete the square, so have that, square it. X squared minus 6x, halve it, which is minus 3 squared plus 9. Okay, so now we must minus 9 plus k equals 0. I can make this perfect square. X is going to be a minus, because that's a minus. Square root of that, 3 squared. And then this bit, well, I can't add, usually I'll add the two numbers together, but I can't here, so I'll just have to leave it as 9 plus k. Okay, k is a number, but they don't tell me where it is. Right, the next bit, find the minimum value of k. So the minimum value of k means the lowest number that k can be, such that the graph is positive for all values of x. Well, let's have a look at this. A graph is positive above the x-axis. Okay? So in order for this graph to be positive for all values of x, it's going to have to be like that, right? Okay? Because anything down here is negative. So if you think about it, I'm just going to rewrite this. Now, if that, let's just look at this y, okay? If that was the minimum value, then it would look something like this. 1, 2, 3. The minimum value would be 1, 2, 3. Would be here, wouldn't it? I'm sorry. That's 3, 2, 1. Okay, because look, the x value is 3, the y value is 1. There's the y value, so there's its minimum. Okay. Now, if that was the case and this was plus 1, then yes, the graph would be positive for all values of x because it's above that x-axis. However, if it was something like this, well, then it would be down like this. Okay? Now that wouldn't be positive for all values of x because down here it's negative. So what they're asking us is, what value must k be in order to make sure that the minimum point is just above or on that y-axis, oh sorry, that x-axis? Well, the answer is, let's have a look at this. When this is positive, it's above it. Yeah? So although that whole graph is positive, but as soon as this gets negative, then the graph gets negative in certain parts. So in order for this to be positive, the minimum value for k must be this. Because if it's 0, then that means the minimum point is on 0 on the x-axis. Okay? So this, the minimum value that this can be in order to ensure that the graph is positive for all x, this here, this minus 9 plus k, must be 0. And in order for that to be 0, well, k must be 9. Because if k is 9, then that ensures that this is the case. If that's the case, then here's the graph, and that's the lowest that graph can be without getting into negative. Okay? Hopefully that helps, guys. I'll talk to you soon.